Now we are going to explain you how to solve one probability problem. Hope you enjoyed this video, and what is the most important, the solution will become clear for you. So, there are B basketball and F football balls in a bag. Alice, Bob and Christine choose one ball at random from the bag in this order. Find the probability that Alice gets a basketball ball, Bob gets a one, and Christine gets a basketball ball. Let's start to solve this problem. First of all, we need to remember that each of three people chooses a ball from the same bag. It means that after every person took a ball, there is minus one ball left in the bag. They take one and don't put it back. It is the easiest to find probability for Alice that she will choose the basketball ball as she makes her choice first and it doesn't depend on previous ones. So, the probability that Alice gets a basketball ball is B divided by B plus F, where B plus F is the sum of all balls in the bag. Now, let's find probability for Bob. If the outcome of one event affects the outcome of another, then the events are called dependent events. Probability for Bob depends on Alice's choice. There are two options what could have happened if Alice got basketball or football ball. First, if Alice got a basketball ball, the amount of them is one less. So, the probability of event B, dependent on event A, equals to multiplying of two probabilities. Bob's probability to get basketball ball and probability for Alice to get basketball ball. In first part of the formula we wrote b minus 1 because Alice had already taken one basketball ball. In second part we just repeat the formula for Alice's probability. The second option is that Alice got a football ball. The amount of them is one less. So, the probability of event B, dependent on event A, again equals to multiplying of two probabilities. Bob's probability to get a basketball ball and probability for Alice to get, in this case, a football ball. In the first part of the formula, we have the same amount of basketball balls, but total sum is one ball less. In second part of formula, we define probability for Alice to get the football ball. Final probability for Bob that he will get a basketball ball is the sum of our two options. Now let's find the probability that Christine gets a basketball ball. In this case, we will have four different options. First, both Alice and Bob took basketball balls. So, the probability of event C, dependent on events A and B, equals formula in which all three people take basketball balls. First part is for Christine. We multiply this for probability for Bob that he takes a basketball ball. And multiply by probability for Alice. Second option, both Alice and Bob took football balls. So, the probability of event C, dependent on events A and B, equals formula, in which only one person took basketball ball, while the other two people took football balls. The third option. Previously, Alice and Bob took one basketball and one football balls. So, the probability of event C dependent on events A and B equals formula, in which Christina took a basketball ball and Bob and Alice took football and basketball balls. The last fourth option is when Alice took football ball and Bob took basketball one. So, the probability of event C dependent on events A and B equals formula, in which Christine took basketball ball, Bob took basketball one, and Alice took football ball. The final probability for Christine that she will get a basketball ball is the sum of our four options.